Section 517.130 of the National Electrical Code specifically addresses the wiring methods permitted for equipment in specific healthcare facilities, which includes dental offices. It mandates the use of grounded metal conduit for wiring to dental chairs. This requirement is in place to ensure patient safety and minimize the risk of electrical shock in a potentially sensitive environment. The rationale behind requiring metal conduit lies in its superior grounding capabilities and its ability to provide a continuous, low-impedance path back to the source in the event of a fault. This low-impedance path is crucial for quickly tripping a circuit breaker or blowing a fuse, effectively disconnecting the power and preventing a dangerous voltage from being present on the dental chair's metal surfaces. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Section 517 specifically deals with healthcare facilities, recognizing the unique electrical safety requirements in these environments. Healthcare environments, like dental offices, pose a greater risk of electrical shock due to several factors. Firstly, patients may have compromised immune systems or be more susceptible to electrical current due to medical conditions or medications. Secondly, the presence of conductive fluid, such as saliva or blood, increases the potential for electrical current to flow through the body. Thirdly, medical equipment often comes into direct contact with patients, creating a pathway for electrical shock. The use of metal conduit in these settings provides a robust and reliable grounding system that minimizes these risks. Metal conduit offers several advantages over non-metallic conduit such as PVC. Firstly, metal conduit provides superior mechanical protection for the enclosed conductors. It is more resistant to physical damage such as crushing or impact, which can compromise the insulation of the wires and create a potential shock hazard. Secondly, metal conduit acts as an effective shield against electromagnetic interference, or EMI. EMI can disrupt the operation of sensitive medical equipment and potentially interfere with patient monitoring. Thirdly, and most importantly, metal conduit provides a continuous, low-impedance ground path. This is essential for quickly clearing faults and minimizing the duration of any potential shock hazard. PVC conduit, on the other hand, does not offer these advantages. PVC is a non-conductive material and therefore cannot provide a grounding path. While it does offer some degree of mechanical protection, it is not as robust as metal conduit. Furthermore, PVC does not provide any shielding against EMI. In the context of dental chairs, the requirement for metal conduit is particularly important due to the close proximity of electrical components to the patient. Dental chairs often have integrated electrical components such as motors, lights, and control systems. These components can generate electrical noise and create a potential shock hazard if not properly grounded. The use of metal conduit ensures that any fault current is quickly directed back to the source, minimizing the risk of electrical shock to the patient or dental staff. Redundant grounding is often a supplementary requirement for critical equipment in healthcare facilities. Redundant grounding involves providing two separate and independent ground paths for the equipment. This ensures that even if one ground path fails, the equipment remains adequately grounded. Redundant grounding can be achieved by using a separate grounding conductor in addition to the metal conduit itself, or by bonding the metal conduit to multiple grounding points. The specific requirements for redundant grounding may vary depending on local codes and regulations, as well as the specific type of equipment being installed. When installing electrical wiring for dental chairs, it is crucial to consult the National Electrical Code and any applicable local codes to ensure compliance. A qualified electrician should be employed to perform the installation, as they will have the necessary knowledge and experience to properly install the wiring and ensure that it meets all safety requirements. The electrician will also be able to perform the necessary tests to verify the integrity of the grounding system and ensure that the equipment is safe to use. In summary, Section 517.130 of the NEC mandates the use of grounded metal conduit for wiring to dental chairs. This requirement is in place to ensure patient safety and minimize the risk of electrical shock. PVC conduit is not permitted for this application due to its lack of grounding capabilities and inferior mechanical protection. Redundant grounding may also be required to further enhance safety. Always consult the NEC and local codes and employ a qualified electrician for all electrical installations in healthcare facilities. Ignoring these specific requirements could have serious consequences and potentially endanger patients and staff. Proper adherence to these guidelines ensures a safe and reliable electrical environment within the dental office. It is crucial to remember that the NEC is a living document that is constantly evolving to address new challenges and improve safety. It is the responsibility of all electrical professionals to stay up to date with the latest code changes and ensure that their work complies with the most current requirements. Regular training and continuing education are essential for maintaining competency and providing safe and reliable electrical services. The selection of appropriate wiring methods is just one aspect of electrical safety in healthcare facilities. Other important considerations include proper grounding of all electrical equipment, the use of ground fault circuit interrupters, or GFCIs, in wet locations, and regular inspection and maintenance of electrical systems. A comprehensive approach to electrical safety is essential for creating a safe and healthy environment for patients, staff, and visitors. The NEC provides a framework for achieving this goal, but it is up to individuals and organizations to implement these standards effectively. It is vital to remember that electrical safety is not just a matter of compliance, but a matter of ethics and responsibility. Every electrical professional has a duty to protect the public from electrical hazards and to ensure that their work is performed to the highest standards of safety and quality. By adhering to the NEC and other relevant codes and standards, electrical professionals can make a significant contribution to the safety and well-being of their communities. Furthermore, understanding the specific requirements outlined in Section 517.130 extends beyond simply knowing that metal conduit is required. It also encompasses a deeper understanding of the types of metal conduit that are acceptable, the proper methods for grounding the conduit, and the specific requirements for connecting the conduit to the dental chair. For example, the NEC specifies different types of metal conduit such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and electrical metallic tubing, or IMT. Each type of conduit has its own advantages and disadvantages in terms of cost, weight, and ease of installation. The selection of the appropriate type of conduit will depend on the specific application and the environmental conditions. Grounding the metal conduit is another critical aspect of the installation. The NEC requires that the metal conduit be effectively grounded to provide a low impedance path for fault current. This can be achieved by using grounding bushings, bonding jumpers, and other approved grounding methods. The specific grounding requirements will vary depending on the size of the conduit and the available grounding points. Connecting the conduit to the dental chair also requires careful attention to detail. The NEC specifies the types of fittings and connectors that are permitted for use in healthcare facilities. These fittings must be listed for the intended use and must provide a secure and reliable connection between the conduit and the equipment. In addition to the specific requirements for wiring methods, the NEC also includes general requirements for electrical installations in healthcare facilities. These requirements cover a wide range of topics, including wiring methods, grounding, overcurrent protection, and emergency power systems. It is essential to be familiar with these general requirements in order to ensure a safe and compliant installation. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and refer to the latest edition of the National Electrical Code for specific requirements and recommendations. It is also important to remember that local codes and regulations may vary from the NEC. Be sure to check with your local authorities to determine the applicable requirements in your area. Compliance with the NEC and local codes is essential for ensuring the safety of patients, staff, and visitors in healthcare facilities. By following these guidelines and seeking professional advice when needed, you can help to create a safe and reliable electrical environment. The NEC is not just a set of rules, It is a set of best practices that have been developed over many years by experts in the field of electrical safety. By adhering to these best practices, you can minimize the risk of electrical hazards and protect the lives of those around you. The importance of proper wiring methods in healthcare facilities cannot be overstated. Electrical shocks can be life-threatening, especially for patients who are already vulnerable due to illness or injury. By following the NEC and local codes, you can help to prevent these tragedies from occurring. Remember, electrical safety is everyone's responsibility. Whether you are an electrician, a healthcare professional, or a building owner, you have a role to play in ensuring a safe and reliable electrical environment. By working together, we can create a world where electrical hazards are minimized and lives are protected.